All right, lesson 15. Today we're talking about solution sets of two or more equations or inequalities. And I could add, we are going to join that by the word and, sorry, or the word or. So when we talk about solution sets of two or more equations, we're going to use these words quite often. So first of all, with exercise 1. Determine whether each claim given below is true or false. Right now, I am in math class and English class. Impossible. Can't be in two classes at once, even if your math teacher is also your English teacher. Right now, I am in math class or English class. That is probably true. I'm not sure where you're watching this video at, so that could be false. You could be in your kitchen, but whatever. Next, 3 plus 5 equals 8. That is true. And 5 is less than 7 minus 1, and that is also true. And I've got an and statement there, so that's going to be true. 10 plus 2 is not equal to 12. That would be false. And 8 minus 3 is greater than 0. That is false. So they are both, in fact, false. 3 is less than 5 plus 4. That is true. 6 plus 4 is equal to 9. That is false, but I have an or statement there. Once one of them is true, my statement overall is, in fact, true. 16 minus 20 is greater than 1, or 5.5 plus 4.5 is equal to 11. That is false, and that is 9, 10, and that is false. So that is, oh gosh, no. So that is in fact false. Oh gosh, if I could only erase that little bit, but that's okay, we're moving on. These are all examples of declarative. I like declarative. We're doing declarative compound sentences. When two declarations in the sentence above were separated by and, what had to be true to make the statement true? If it's an and, both declarations have to be true. So both declarations must be true for the statement to be true. When the two declarations in the sentences above were separated by an or, what had to be true to make the statement true? At least one declaration had to be true. For that to be true, right? Cool. Right, next up, just talking about a discussion here. The word and means the same thing in a compound mathematical sentence as it does in English. If two clauses are separated by and, both clauses must be true for the entire compound statement to be deemed true. So there's my English. I'm the English teacher in me. Okay, if two clauses are separated by and, both clauses must be true for the entire compound statement to be true. The word or also means a similar thing in a compound mathematical sentence as it does in English. However, there is an important distinction. In English, the word or is commonly interpreted as the exclusive or one condition or the other is true, but not both. In mathematics, either or both could be true. Okay? In mathematics, either or could be true. So if two clauses are separated by an or, one or both of the clauses must be true for the entire compound statement to be true. One or both. Okay, so and has to be both, or has to be one or both. So example 1, solve each system of equations and inequalities. Okay, I'm going to do A, and then I'm going to push pause. So first of all, I'm going to subtract 8 from both sides and get x equal to negative 5, or add 6 to both sides, x is equal to 8. In set notation, I would write that as negative 5, comma 8. That's my set of solutions for both equations or inequalities. All right, so I'm going to push pause. Please try B, C, and D and check your answers with my answers and see how you're doing. All right, let's look at these. So here I solved it, got a solution, or I solved it, got a solution. It's or, so I can list both answers as part of my solution set. Here, I solved it, got a solution, got a solution. They're the same solution, and luckily they need to be the same solution because this says and, so I can list that as a solution set. Here I solved the left side, I got W equals 9, and I solved the right side, which didn't need solved, and got W is greater than 9. This is an and, so both of them have to be true for me to write a solution set, which is why I wrote empty set or empty set. Okay, there's no solution to that system, that group of equations. So here, using a different colored pencil, graph the inequality x is less than 3 on the number line below part C. So x is less than 3. Ooh. Let's try that again. So x is less than 3. Using a different colored pencil, graph the inequality x is greater than -1 on the same number line. Using a third colored pencil, hold on, there we go. Darken the section of the number line where they overlap, is what it's saying. Beautiful. Okay, let's go again. Using a colored pencil, graph the inequality x is less than -4. Oh. Sorry about that. X is less than -4. Using a different colored pencil, graph the inequality x is greater than 0. Using a third colored pencil, darken the section of the number line where x is less than -4 or x is greater than 0. Interesting, right? Cool. Now, if I actually look at this and try to write my final answer, if I look at the first part of exercise 2, it looks like -1 to 3 with an x in the middle is my solution. So x is bigger than -1 and x is less than 3. It has to satisfy both, right? There's my and. On this bottom one, I actually have -4, x is smaller than -4, or x is bigger than 0. And that satisfies my or, and that's how I would write. I might get a little fancier, but basically that's how I write my solution set. Right, graph the compound sentence that x is greater than -2 or x is equal to 2 on the number line below. So if I look at -2, first I'm going to do the equal to, or greater than. Now, how could we abbreviate this? And you guys should know this by now. X is greater than or equal to -2. This right here says, with words, greater than or equal to. Next, rewrite x is less than or equal to 4 as a compound sentence and graph the solutions on the sentence to the sentence on the number line below. If I write it as a compound sentence, that means I've got a connector in between. I'm sure there's a better word for what I said, connector, but it gets my point across. Okay, I'm writing it in big words with a connector in between. And if I were to shade it in, I would have a closed dot at 4, shading that way. All right, into example 2, graph each compound sentence on a number line. So x is equal to 2, or x is greater than 6. There's no 6 on this number line. Huh. Okay, mistake, not mine. I need a 6. So I've got that, open dot, shaded this way. B, x is less than or equal to 5, -5, sorry. Less than or equal to -5, I'm out of space, or x is greater than or equal to 2. Very cool. Rewrite it as a compound sentence and graph the sentence on a number line. So here I have x is greater than or equal to 1 and x is less than or equal to 3. That's when they're connected like this, it's an and statement. And that's really important to see. Now I'm going to graph the 1 and the 3. So it's bigger than 1 and smaller than 3. That means it has to be in between those 2 points. Exercise 3. Consider the following 2 scenarios for each. Specify the variable and say, for instance, W is the width of the rectangle, for example, and write a compound inequality that represents the scenario given. Draw its solution set on a number line. So here we have students are to present a persuasive speech in English class. The guidelines state that the speech must be at least 7 minutes, but not to exceed 12 minutes. So let's just say let X represent the length. Oh, I don't know why I said 2. Oh goodness, hold on. Sorry about that. So we're going to let X represent the length of time of the speech. Therefore, we've got X can be bigger than or equal to 7, and X is going to be less than or equal to 12. So if I write that properly, there we go. I'm sure I don't have enough space here, so we're just going to go 7, 8, 9, 10, 11, 12. And shade in between. Cool. Children and senior citizens receive a discount on tickets at a movie theater. To receive a discount, a person must be between the ages of 2 and 12, including 2 and 12, or 60 years age or older. So we're going to let X represent the age of the moviegoer. My handwriting. So X represents the age of the moviegoer who gets a discount. That means that the discount goes between 2 and 12, including 2 and 12, or greater than or equal to 60. So that's going to be sort of hard to, so my number line is not going to be drawn to scale, but I'm going to have a 2 and a 12. So in between 2 and 12, or greater than or equal to 60. Cool. All right, determine if each sentence, if each sentence is true or false and explain your reasoning. Sort of a review. So I've got 8 plus 6 is less than or equal to 14. If I subtract 6 from both sides, I get 8 is less than or equal to 8, which is true. And 1/3 is less than 1/2, which is true. And it's an and statement, so in fact, we are true there. I'm going to do, well, we can go ahead and do it. So if I add 8 to both sides, I have 5 is less than 8. Subtract 13, 10 is not equal to 13. Sorry, 23 minus 13 is 10. It's an or statement. This one is true, this one is false. Therefore, the whole thing is in fact true because it has to be one or both. Solve each system, graph the solution on a number line. Here I've got X is equal to 9, X is equal to 15. Dot. And my solution set. That's a beautiful squiggly, isn't it? I hope I'm making you feel good about your squigglies. And last one. Add 8. 5x is equal to, that is negative 15. X is equal to negative 3. Or minus 1 minus 1. X is equal to negative 11. 10, 9, 8, 7, 6, 5, 4, 3. Dot. Solution set. Oh, do the smallest one first. Cool. Okay, you guys check these. I'm going to push pause, okay? You can do these on your own. There you go. Check your answers. Last page, a poll shows that a candidate is projected to receive 57% of the votes if the margin for error is plus or minus 3%. Write a compound inequality for the percentage of votes. So 57 plus or minus 3, that means the smallest will be 54%, and the largest will be 60%, with X being the percentage of votes. Mercury is one of the two elements that are liquid at room temperature. Mercury is not liquid for temperatures less than 38 degrees F or greater than 373.8 degrees F. Write a compound inequality for the temperature at which Mercury is not solid. So at temperatures less than 38 or temperatures greater than 673.8, with X being the temperatures in degrees Fahrenheit, not liquid. Liquid. All right, that's all I have for today. See you tomorrow.